Greetings, class. We are proceeding to the next lesson, 9B. And we are going to be looking at the a few things that are very important to recognize in respect of where we stopped at 9A. Please go back carefully to 9A and see the notes and the review I did very carefully. I want to mention that when we are now entering these materials into the plant breeding program, we need to recognize that when we entering them, the issue of crossing, selection, and evaluation is very key. That is a triangulation that I am referring to in terms of what we need to do. So we will have to progress on the basis of what I'm showing you here now, so that we are able to understand where we are going to. And it's very important here that we look at the diagram, the next two diagrams, in retrospect back to the plant breeding framework. In that plant breeding framework, we actually now have or are dealing with the bottom line of the plant breeding framework. We've moved from pre-breeding to that part now. And I want to indicate something here that is very important in this diagram. And that, remember, we did an assessment of plant breeders' needs, of the producers' needs. Those are the farmers. We found out that they are interested in maize in maize, for example, that is white grain, high yielding, good plant stature. But we also know that we have the other aspect that is good in this other maize. So we choose or identify the plant genetic, the plant germplasm from the genetic resource of maize. And when we do that, we grow them, as you can see, the two parents. And then, of course, we progress to carry out evaluation by a chronological order method. Remember, I asked that in the previous test. And then in this chronological order methods, we start to evaluate how the plant performs. Then at stage 6 here, during the flowering, we have the silk, which is the reproductive part, and we have the tassel. And we have to make these plants female and male. We do that by emasculation. Then when we have done that by emasculation, we can now cross the preferred parents that we actually identified here. We do a crossing. Then when we do the crossing, we allow these plants to go on up to the stage 8 here. And of course, at the stage 6, as you can see, when we cross, we will have to evaluate the crosses to make sure that they have actually resulted in a fertilized plant that has formed this zygote, and we allow it to progress to this seed here. And in the process, we have identified these plants inside this field that seem to be promising. When we have done the crossing here, it is very important in selective breeding to actually bag the, the fertilized plants to avoid them getting contaminated by the unwanted pollen from the other plants. Is a very short time to have fertilization going on after pollination, and therefore this bagging is very important. And when we remove the bags from these plants, we can then harvest the seed and further select from them those that are offspring that are promising. And we go through the same process and we select superior progeny successively, evaluate them, and do the selection again and again and again across the successive cycles to maximize the genetic gain. That's very important for us to recognize this process. Very, very important. If we can understand this process in terms of the gender method, we'll have understood about the strategies that are used to breed new cultivars. Very, very important. Look at this, make a few notes very briefly about it, because any other subsequent test and assessment in terms of take-home homework or assignment is going to be based on this part, and in retrospect to the breeding framework that I have actually been emphasizing, that you answer those questions to get to the point of the pre-breeding to conclude as we enter the materials into the crop improvement or the plant improvement program. So basically, in that cycle, we have to remember this, that if, let us say, the generation cycle was F2, that F2 will go through the entire process just like this one here, and then we get the F2 seed harvested and started in the next cycle of generation to to being planted and then going through this, and you can see the importance of the chronological order method of evaluation. And we now get the F3 seed harvested from the F3 plants, starting right from the youngest germinant into the seedling, into the vegetative stage, into the flowering stage, where we do certain things that afford crossing, and then moving the thing into chronological order to the fertilization, the maize that has now to mature into F3 seed. Then this 3F seed will again go into this process now to grow them as F4 plants, and this is what is called the cycle of generation. It's very important for us to remember that. It is going to be as brief as I can be on this one, but do remember that is the standard breeding, which can take a long time. This cycle of the standard breeding may look like very short, but it's not very short. It's not very short at all, because we have to go through the generative and derivative methods, and you select from those using the selection strategies that will also repeat themselves through successive crossing and selecting and evaluating. So here again, when we compare the standard breeding and what we call the plant biotechnology breeding, let's just call the selective breeding as the standard breeding. It is the conventional one, the classical one, which can take a very long time, as we said before. And then we have the plant breeding one, the modern plant breeding technique, which is now called the genomic selection. And you can see that in the standard breeding, we make crosses, as I have already shown you. Then we inbreed the isolated lines. We inbreed. We inbreed by actually crossing them again. And then, and as you can say, it can take 5 to 7 years or even longer. And then, of course, we get them evaluated as small scale trial. And remember, there are the subsequent cycles of generation. The more we can decrease those cycles, that, it doesn't have to go to 30 cycles, to 20 cycles, to 15 cycles, we can reduce them by increasing the selection intensity and by increasing the accuracy of selection. Then we put them in small scale trials. And then, of course, we can move them into large scale trials. And this is where we may have a spin-off to sell or release cultivars 10 to 12 years, as you can see. Just in the bigger cycle here, it is 5 to 7 years. But now by the time we're getting to the sale or release of cultivars, it's about 10 to 12 years. And then, of course, we can go through this again to go to Okashana 3. We have identified what Okashana 3 or what maize hybrid something, HB something, is missing, and we go through the process in the bigger cycle. This, compared to genomic selection, is we make crosses. When we make the crosses, we can harvest the pollen or the embryo when, not the embryo, the gametes as they are that are in haploid condition that are very good. And of course, when we double, for example, we have done an inbred cross. We can take those crosses, we take while they are still in a haploid state, and we double the chromosomes. They are called the doubling haploids. Then we have the genotype and predict the value. Then we have small scale trials. Then we have the small scale trials and the large scale trials going into a model. Usually the model is often a software, and in that model there are all other things that are inbuilt to actually look or predict the genotype and predict the value. Then when we do that, we go through the process where we can now move to large scale trials. Then we sell the seed or release the seed. And this takes from 6 to 7 years. If you compare with the standard one, this takes from 10 to 12. So at least around here, we have halved the time if we are obedient to the breeder's favorite equation, and we are recognizing the, improving on selection intensity, selection accuracy, and doing the crosses that are generating a promising genotypic variants, the genetic diversity that gives rise to the gene additive effects. All right, as you can see in here, where we have about 2 years to get the crosses in genotype and prediction of value. And then from here, small scale to large scale trials where we can release. It takes about 4 years. 4 years plus 2 years is about 9 years. So really, having from 6 to 7 years of this total is just a range. It's not a formula where you turn on the switch and it will take exactly that time. And of course, as you can compare, it is in sharp contrast to the standard breeding one. So a lot of the modern techniques in plant breeding are beginning to emphasize on this bit here, and it goes to what we indicated as a faster way of doing some things. This is what I can say, and I would like us to really get to this point and stop there. Then we will start to get into lesson 10. Lesson 10 are the breeding methods common for both self and cross-pollinated crops, and we'll be seeing this a little bit later. In the meantime, please read carefully, make a few notes in terms of this short aspect of the lesson 9b in connection with lesson 9a. Remember, lesson 10b is going to be the last part of this lecture. Thank you.